Welcome to this lecture on TF-IDF. So in this lecture, I'm going to demonstrate how the TF-IDF factorizer works. So let me start with the demo. First, we will create a notebook file, Jupyter notebook file. So TF-IDF factorize method is used to transform the given documents into vector form, where the features from documents will be extracted and the weighted scores to measure how important word is within a document or across the document that will be calculated. So the weighted scores describes how important a word is within a document related to the corpus. So we have to create a corpus first. The first step in this implementation is while creating this Jupyter notebook file, you have to rename it. So we'll use a TF-IDF demo as a file name. So first we have to import necessary libraries. So in TF-IDF, TF stands for term frequency, IDF stands for inverse document frequency. In the previous lecture, we discussed how it is to be calculated. Term frequency is measured to represent how important a word is within a document, whereas IDF measures how important a word is across a document. So we have to take a product of TF-IDF to generate the score, weighted score. So the weighted score, when it is high, that shows that a word is important within a specific document for a given purpose. If the score is high, TF-IDF score is high, if it is low, that means that the word is common across many documents in the corpus. So first we will import necessary libraries. So I need a scikit-learn package for this. So already it is installed. From sklearn feature extraction module for text processing. So I'm going to import TF-IDF vectorizer. And then I need one more library, that is pandas, to create a data frame that stores the result of TF-IDF vectorizer. So it helps us to display the data. So pandas as PD, I'm using alias name to it for open means. So after importing necessary libraries, I'm going to create a corpus. The corpus may be created by collecting dataset from Kaggle or other machine learning repository. Otherwise, you can extract comments, post from the social media websites, uh, checking the privacy policy and all. The third method, maybe you can prepare documents offline, PDF or Word documents, .txt file, offline documents you can consider. So here in this example, I'm going to create a corpus by considering sentences document. So each sentence is treated as a single document. The first sentence is, this is the first lecture on TF-IDF. Then the second sentence I'm considering, this is the first demo on NLP technique. So the third document is second lecture is on POS. So these are the three documents I'm considering. So I run this now. The next step is initializing a vectorizer. Initialize vectorizer. So I'm creating a target variable for this. Vectorizer is equal to TF-IDF. So I'm invoking the class, invoking this module. While initializing this vectorizer, you can also pass parameters. For example, stop words is equal to English. If you want to remove common words appearing in English sentences, so the common words may not be important for text data analysis, so we can remove those words. So you can use stop words remover. You can specify English stop words. Then you can also specify n-gram range is equal to, for example, 1 comma 2. This shows that you are considering the unigram and bigram. Then we have another attribute, that is max features, maximum underscore features. I'm considering top 5 features. Okay. Now, so you have to check why this error. There is a typo. So you have to use proper feature name, parameter name, otherwise it will show you error. So now my translation is done. Now I want to create a TF-IDF matrix. TF-IDF matrix is equal to, so vectorizer dot, you have to call the fit underscore transform function. You have to pass the source documents. Already we created a corpus, so I'm passing docs as a corpus name in it. So this will fit the TF-IDF vector model into the data, and it transforms the documents into features, where features are words extracted from each of these document. So I need to give one comment statement also for this to improve the readability. So this is for fit and transform the documents using IDF. So I run this now. So the next step is generating a array. Create array from a matrix, dense array from a matrix. So not do this, I'm going to have a variable TF-IDF array is equal to, so TF-IDF matrix dot to array. So we are transforming this matrix into dense array because the matrix contains a sparse representation, sparse matrix representation, where many zero elements may be there. So I need to create a dense matrix. So for that I'm calling the function to array. Let us run this now. TF-IDF and this matrix variable should be exact matrix name, exact name, TF-IDF underscore matrix. So now run this. So it was fine. Now I'm going to generate features. So we need to get feature names now. So feature names is equal to vectorizer dot get feature names. So I'm using this method to get the features from the TF-IDF array. So I've created already the TF-IDF array. So now I'm getting a feature names from the vector space. Now let us run this. It works fine. So in the next step, I'm going to create a data frame to display the results. Display results. So I have a variable df that represents data frame is equal to pd, that is pandas data science library object. So pd dot data frame. You need to call this class. So in this class, I'm going to pass both the array name TF-IDF let's go array, and columns, what are all I want, columns is equal to feature names. Okay, so here in this statement, what I'm saying, I'm having an array, and the columns names of that matrix should be, data frame should be the features extracted from the document. So all those are words. So column names would be words, and the row wise we are going to have documents. The values in the matrix would be TF-IDF uh, results would be scores, weighted score, that is representing how important a word is in a document related to a corpus. So we'll print this now. To print this, we can use the print statement, print df. Now run this. So this is the result of this TF-IDF. So it considers both unigram and bigram features, and maximum top features are considered, and we also remove the stop words. So we consider only essential features. So here you can see in document 1, so the score is very TF-IDF score is less, it is 0, but IDF, the word IDF, it is having higher score 0.8, and that means that when the TF-IDF score is high, that means that the word is important in a specific document. And similarly in document, the next document, the TF-IDF score for IDF is low, but it is high for the word demo and demo NLP. So that's on this lecture. So in this lecture, we have demonstrated how the TF-IDF tracer works by applying the TF-IDF tracer module and Pandas data science library. So we have seen how to create a corpus, how to remove the stop words, how to set bigram, unigram, that is features type, and maximum number of features allowed. And we transform the documents into vector by generating features. The features are words, which are analyzed how important the words are in the given documents. Using the weighted score, we have analyzed the importance of features. So these features can be quite useful when you build a model to learn features, to understand, to classify the documents, or to extract relevant information. So this will be quite useful. So thank you so much. In the next lecture, we will discuss how to apply parts of speech tagger for various applications. So as mentioned earlier, so TF-IDF tracer plays very important role in text classification and sentiment analysis, document classification, text similarity measurement, search engines, Google, for example, and in many uh, social media applications also. So thank you so much. In the next lecture, we'll see the demo on POS, parts of speech tagger.